Hello and welcome back. My name is Amir and this is day 22 of Advent of Code 2022. I have already solved this puzzle, so there will be no live coding in this video, but I will show you the link to my GitHub channel in the description as always, and I will show you the code and the way I thought about solving the problem. So let's go and start it. The first thing is that we have been given an input like this, which is two part. The first part is a map like this map that we have here, and some direction rules that we should follow. So the puzzle has, as always, a few rules that we should follow. The first one is that these are walls that we cannot cross, and we are starting at this, which is the leftmost of the topmost cell in the grid, which is not space, which is not blank. So we're starting here, and based on these directions we will move along. We are always here and we are facing to the east, so we are facing in this direction, and based on the numbers that we have here we will go along. So if for example we are here and we get like 2, then we will move here and stop, but if we get 3 we will move 3, and our third step is a wall, so we'll stop here. So when we hit the wall we will stop. So if we start here, whatever our number is greater than 2, we will stop here. Then we have R and L. R means rotate clockwise, and L means rotate counterclockwise only. And we will take them one after another. So our first instruction is 10, so we should move 10. Then we should rotate clockwise, so we will come here and we stay here, and then we will face downwards. Then we get 5, we will move 5 steps, 1 2 3 4 5, and we will end up here. Then there is N, which means turn counterclockwise, and so forth and so on. The thing is, if we are like for example here and we are um, facing to the east, so we are in this direction, and we get like 2 or 3, then we should move here and then start from here. So we will roll back to where we start, which we will never drop into the void here. So it's like a circular pattern. It's the same for the columns. So if we are here and we face up and we get like 3, then we will go 1 2 and 3, will end up here. And the other rule is that for example if we are here and we go up, we will end up in the wall, so we will bounce back to where we were. So these are all the rules. Let's see what the code is then. So the part 1 is pretty straightforward. I will just get the input and split it and get the first one to get the maze, and then the directions. I will just provide the regex like this. I will provide the regex like this to get the directions in an array. Then we have the max rows and max columns to find out if we are falling out of the borders, our current row and current direction, and our pointer direction. Okay, then we have a facing value. This is this part. In the end, when we want to provide the answer, we should look at our direction, which way we are facing. So if we are facing right, then we should add 1 to the final value, which is provided here. 1000 times rows plus 4 times columns plus the direction or facing. So this is the facing, this is the move function. We will get to it in a minute. And then based on every direction that we found in this directions array, if the direction is L, then we will change our direction. So if we are facing like top, then we will face left, And if we are facing left, like here, then we will face down. So it's like this. So if we are here and we are facing like this and we get an L, so we'll go counterclockwise and it will be top. So right, like this. And otherwise, if it is an R, still a direction but on the other way, so we will just change the direction in these two. And otherwise we will get a number like for example like this, like 10. Then we will, based on the number that that direction provides, we need to move. Now we need to check if we hit a wall and stop, otherwise then we will update our rows and everything as we move on. So what is the move function? The move function is basically we're just getting the current direction based on the direction that we have, because we're going to change the directions, and we just move the pointer of our person in the map, and just a bunch of if statements here. If our row is more than the max row, if we're falling out, then we will go back to 0. Otherwise we will just going to left or to the right, and so forth and so on. So this is pretty much it about this, and in the end, as the puzzle suggests, we're just doing a calculation here and providing the answer. So it's a pretty forward and pretty straightforward puzzle to face in part 1. Part 2 is a bit more tricky. So let's see what the part 2 is about. Okay, in part 2 we will see that we are looking at an input device, which is a large cube, and each face has like 50 rows and 50 columns. So it's something like this shape that you can see here. So every one of these is a 50 by 50 face of a cube, represented in like a 2D. So all this part is a face of the cube. So if this is front, 4 is front, then 1 is top, this is left, and 2 is like here, and so forth and so on. So for example, if we have this picture, it will be something like this. Is here, then we have like this face, which is this face, and this will be 3, and the top is going to be 1, and you know what I mean. And this is the other face, and so forth and so on. So it will be like this. It will be wrapped around like a cube. And the other thing is that if we have, for example, 6 here, it would be a valid map. So this can change from puzzle to puzzle. Then we will move on in this puzzle the same way that we moved in the puzzle number 1, but there is one more thing to look at, which is very, very important, and that is we are not moving in the same fashion as we did. So something like this, for example. Now, I don't know if it's valid or not, but it's something like this. And for example, if we are here in this row and we are facing in this direction, and we would get like, for example, 4 steps. Our first step is here, our second step will be in void, but it's actually not void. We will bounce back to here. So it will be like, as we are going down, going up, we will go here in the top, and then we will move in this direction. So when we are falling out, or when we are changing faces, so to say, we're both changing the direction and our position, so everything is going to be changed. And that's again because this uh, edge will be on this edge as we fold the cube together. So this will be here, and this edge is here, and this will come here, this will come here, and this will be like here. So in other words, this whole cube shape will be something like this, and we are moving from here to here, then to here, and then to here, something like this. This is very important to have in mind when we are solving the puzzle. So as you can see, there will be like 6 different faces, and we will have like 6 different if statements for each of the faces as we are moving from one to the other one, which makes it a lot of code. Okay, let's see the code then. I think it's enough with the drawing. So in the code for part 2, everything is the same. The only thing that is being changed is the move function, and the same as part 1, we are moving until we get to a point which is void. These 6 statements, which are kind of the same. The first one is from 0 to 49, which is first cube, and the column is between this one and this, between 50 and 90. This is the row, and this is the column. So this, if we are facing in this direction, if we are in this face, what should we do? And if our pointer is looking to the top, and then its row is 0, then we would come down. So if we are here in one of these, if we are here in one of these and we are facing in this direction, then we will fall out here. So this is taking care of these matters, these different 6 rows, and these different 6 if statements. And then when this is done, we will check out what is our direction, and based on that we will reduce or add we will decrease or add the row pointer that we have. And yeah, that's basically it. Too many ifs here, and then at the end we will just add the values together like here and do a multiplication. So again, the link is in my description. I hope this drawing has helped you understand the puzzle much better. Thank you for watching my video. Hope to see you next day. See you tomorrow.